In this lecture, we are going to discuss about the calculation of residue at simple pole. Pole of order 1 is called simple pole. Residue at simple pole. If Z equal to A is a pole of Fz of order 1, then Lorentz series expansion of Fz equal to sum over n ranges from 0 to infinity a n z minus a to the power n plus sum over plus here z equal to a is a pole of order 1. So principal part will contain only single term, that is z minus a. In the next step, we can write this as z minus a fz equal to sum over n equal to 0 to infinity a n z minus a to the power n plus 1 plus b1. Therefore, limit z tends to a, z minus a fz. Here this is analytic part, so this is equal to 0. Will give you b1, that is coefficient of b1 is the residue of fz at the simple pole z equal to a. Therefore, residue fz at z equal to a is my limit z tends to a, z minus a fz. This is a formula for finding residue of the function at a simple pole z equal to a. If fz can be represented by phi z by psi z, where psi z is given by z minus a f of z, and f of a is not equal to 0. Multiplying by z minus a f of z, then z minus a phi of z psi of z. Okay. Now taking limit z tends to a in the left hand side and right hand side, we will get this one. Limit z tends to a, z minus a. Now this phi z and psi z we can expand it by Taylor series expansion about the function, about the point z equal to a. That is, we are going to write a Taylor series expansion of the function phi z about the point z equal to a, which is my this one, phi of a plus z minus a phi dex a plus z minus a whole square by 2 factorial phi double dex a plus dot 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 divided by psi of a plus psi dex plus z minus a psi dex a plus z minus a square psi double dex a by 2 factorial plus dot dot dot. if we put z equal to a, this will be 0 and psi of a will be 0. Here psi of a will be 0. This is a minus a will be 0. So psi of a is 0. This is of the indeterminate form. So using L'Hospital rule, I will get fx this denominator derivative of denominator, that is phi of a. Here first I will take this as a first function and this is second function, that is z minus a pi dex a plus dot dot dot. Then again this is constant, here z minus a square, so 2 z minus a pi double dex pi dex a, okay, pi dex a, not double dex a, plus boson. In the denominator, this is constant, so this is 0. This will give you psi dex a plus dot dot dot, that is power containing z minus a. Here there will be one limit z tends to a, okay. Using L'Hospital we will get this one. So here if I put z equal to a, this is 0, this will be 0. Here this term containing z minus a will be 0. We will left with this one, that is b1 equal to pi of a divided by psi dex a, provided my psi dex a must not equal to 0. So residue at the simple pole of fz at z equal to a also can be given by this formula, that is psi dex a, okay. Now we are going to solve some example. So example, find the residue of the function function 1 by z square plus 4 fz equal to 1 by z square plus 4. So solution, poles of fz are, what are the pole? Pole can be obtained by equating the denominator to 0. This implies z equal to plus minus 2i. Our pole of fz are simple pole of fz, simple poles of fz. So residue fz equal to 2i, residue of fz as z equal to 2i is equal to limit z tends to 2i z minus 2i fz, okay. Fz, what is fz? Fz is my function z 2i z minus 2i 1 by z square plus 4 can be, now these are the factor of 1 z square plus 4, so I can write this. I will get the same thing, z square minus 2i square, that is 4i square is minus 1, so this is plus 1 plus 4. Now I am writing the, instead of this I am writing the factors. Z minus 2i z plus 2i. So this factor cancel out. This is limit z tends to 2i 1 by z plus 2i, okay. This is equal to 1 by 4i. Again residue at z equal to minus 2i, z equal to minus 2i, that is equal to limit z tends to minus 2i z of plus 2i fz, okay. Now writing the same thing, limit z tends to minus 2i, okay, minus 2i z plus 2i. Now writing the given function by using its factor, I can write this one. In place of z square plus 4, I can write this one. This factor cancel out. This is limit z tends to minus 2i minus 2i. This is minus 2i. This is minus 2i. So 1 by z minus 2i. This is equal to 1 by minus 4i. That is minus 1 by 4i. These are the residue at simple pole. Next, take another function. Find the residue. Find the residue of the function fz given by cot pi z minus a. Okay. Now solution. Poles of fz are obtained by, first I will write this function in this form. This is cot, so this is cos pi z by z minus a sine pi z. Okay, poles of fz are obtained by equating the denominator to 0. I am writing denominator in this form. This is equal to 0. This implies z minus a equal to 0, or sine pi z is equal to 0. This implies z equal to a. Z equal to a is a simple pole. Here sine pi z is equal to 0 and sine is 0 at pi. So sine is a periodic function. I am writing m pi. That means this implies sine pi z is equal to sine m pi. That means pi z is equal to n pi. This implies z is equal to n, where n belongs to the set of real numbers. Therefore, z equal to a is simple pole of fz, and z equal to n are poles of fz of order 1, and z equal to infinity is the limit point of the pole. Limit point of the poles of fz. Therefore poles of fz, therefore z equal to infinity is non-isolated essential singularity. Okay, non-isolated essential singularity. Residue is defined in the isolated essential singularity. So we are going to find how residue at simple pole of order 1, that is z equal to a and z equal to n. So residue at z equal to a is limit z tends to a z minus a fz, which is equal to limit z tends to a z minus a, what is fz, that is cot of pi z by z minus a. This cancel out. This is equal to cot of pi a. Okay, next residue at z equal to residue at z equal to n is obtained by putting the function phi of a by using this formula phi of a equal to side x a. Here what is phi a? That is a residue at z equal to n, and z is given by this formula. I'm going to use this formula. Here our phi of a is cos pi z, cos pi z, cos pi z. So here my a point is a, so these are n. Okay, so replace all z equal to a by n. So this is n, this is n, this is n pi, and psi z will be my z minus a sine of n pi, or pi z pi, z pi sine of z pi. Okay, z pi side x z will be my sine z pi plus sine z pi, then z minus a pi cos of z pi. Okay, therefore phi x n is equal to sine n pi. Sine n pi is my 0, then this is n minus a, this will be pi cos of n pi. Okay, this is 0, so this is n minus a cos of pi cos of n pi. Therefore residue at simple set, residue of fz at z equal to n and ranges from 1 to infinity is given by phi of n by phi x side x n, side x n. So phi of n is my cos of n pi, cos n pi, cos n pi divided by pi n minus cos of n pi, okay, cos of n pi cancel out, this is equal to 1 by n minus 1 a pi. Is it okay? Yeah, which is the required answer. With that I would like to conclude. Remaining will be in the next lecture. Thank you.